Okay, 8.4, which is a new assignment this week, talks about angles of elevation and depression. And this all focuses on different types of viewpoints when referring to using sine, cosine, tangent, creating right triangles. So, as you'll see here, I'm going to just refer through the notes in this section and talk about a couple example problems. Nothing is new, in a sense, for calculation, sine, cosine, tangent. It's just a little bit different language. So an angle of elevation is an angle formed by a horizontal line and the line of sight to a point above. So if you're here and you're looking straight out and then you go ahead and look up, such as a bird or tree at the top or whatever, in the plane of this example, that is what is creating an angle of elevation. So then if you were to go here and draw a line down, for example, now you have a right triangle. So that is in a sense of how this is going to be used. The angle of depression is if you're looking straight out and you look down, okay, at something on the ground or something below you, that is what is creating an angle of depression. That is, and then an example, you'd sketch this line up here and creating your right triangle. So if you're just looking at you'll notice your angles are alternate interior angles, therefore they are congruent. So depending on your point of view, you're dealing with two congruent angles here. So if you're the top of this tree and you're looking out and looking up at this person up here, that's going to be angle of elevation. If you're here, all depends on point of reference. If you're here looking down, that is creating an angle of depression. But if you're here looking up, an angle of elevation. The bird looking down is creating an angle of depression. Okay, and then so a lot of it will be word problems in this scenario. Okay, so in this example talks about an air traffic controller at an airport, cites a plane. Think about plane being up in the air at an angle of elevation. Here's an angle of elevation. Here's the air traffic controller. Here's the plane. The pilot reports the plane altitude 4,000 feet. What is the horizontal distance between the plane and the airport? Sketch a triangle. Okay, here's your point of reference. Opposite over adjacent is going to be tangent. Tangent of the angle. Opposite segment over the adjacent. 4,000 divided by x. Trick you guys are learning is you can switch these two when your variable's in the denominator, and you get that the answer is 4,601 feet. Okay, so all depends on your point of reference. For your angle of depression, forest ranger is a 90-foot observation tower, sees a fire. Angle of depression of the fire is 7 degrees. So looking out, the angle of depression is 7 degrees. So if this here is 7, remember, this has to be 7 as well because of the alternate interior angles theorem. We now have an opposite over adjacent. Therefore, again, tangent of 7 equals 90, opposite over adjacent. So on and so forth. You can go on there to solve it. One thing to also remember, if this is 7 degrees, this here has to be 83 because this is a 90-degree angle. It's creating a right angle. If this is 83, we have opposite over adjacent, but now it's no, that would be right. Tangent of 83 equals opposite over adjacent. You solve that one out, and you'll get the same answer of 733 feet. So when you're looking at this homework problem, there's an example number 4. It's a little bit more difficult challenge, and so on and so forth. When you do 31 and 34, okay, they are going to be optional questions. They are definitely challenge questions you can refer to. Again, they will be optional, but I do encourage you to take a look, refer to my notes if you have to, but that is definitely a extension of how you can use sine, cosine, and tangent in multiple ways to figure out pretty much anything that you want to. So refer to these notes, check out YouTube videos. There are tons of sine, cosine, tangent videos out there. Nothing new here except a little bit more vocabulary.